All right, good morning. So we're going to get started. My name is Wade Wegner, and I'm the technical evangelist for Windows Azure. And today I'm going to be talking to you about building Windows Phone 7 applications using the Windows Azure platform. And first, what I thought I would do is provide a little bit of background as to who I am. It seems a bit existential for Las Vegas, but I think it'll give some context because I am a Windows Azure evangelist versus Windows Phone 7. And so a lot of the perspectives I have will be based on my experiences and expertise with Windows Azure rather than Windows Phone 7. And so some quick background. As a technical evangelist for Windows Azure platform, there's a number of things that I do, one of which is I co-host with Steve Marks a show called Cloud Cover on Channel 9, which if you're interested in Windows Azure or you like some goofy, geeky humor, I encourage you to take a look at. I also build a lot of resources for developers, demos, and so forth. And in fact, this talk is based off of a toolkit that my team, as well as folks from Windows Azure and the Windows Phone 7 teams, have been working on to build out a toolkit to make it easier for Windows Phone 7 developers to use Windows Azure. And so a lot of what I'm going to be talking about today is based on the experience building out this toolkit to enable these different scenarios. Now, I also wanted to share with you some assumptions I have on you guys. And so my talk is kind of based on these assumptions, and I hope that these are pretty accurate assumptions. But if nothing else, you'll understand where I'm coming from and why I'm sharing certain information. And so the very first assumption is that you're a developer. I'm assuming that you're interested in developing these applications because you're building Windows Phone 7 apps. Similarly, my assumption is that if you're building mobile and phone applications, you're probably looking at other mobile platforms as well. And so that might make something like using Windows Azure or cloud computing a little bit more compelling because you're looking at finding a way to provide a set of core services that can be leveraged across different platforms. And so essentially, one of the questions is, well, why the phone and cloud? Other than the fact that that picture is just incredibly cute and makes me smile every time I take a look at it, really, why is it that phone and cloud are a compelling scenario? And I think one of the first pieces is, at least from my perspective, is that the cloud really levels the playing field. So if I'm a small shop and I build out an application, I have the ability to leverage resources in the cloud to scale it up to a pretty significant level to serve up resources to my consumers and the users of my applications. And so I don't need to necessarily have that big upfront investment in a bunch of resources or servers that I run on premises. I can provision and scale as I need to based on the consumption of my application. And similarly, through the cloud, I have the ability to tap into a very large pool of resources from which I can pull. Also, having these resources set up as services available through the cloud really makes it possible to provide these core capabilities across different device platforms, since much of the functionality is built into services that are running outside or off of the actual application and device itself. Now, why Windows Phone 7 and Windows Azure? So a couple of things. I'm assuming that most of you have some grounding with Windows Azure, or you might not be here. But one thing to note is that Windows Azure is a platform as a service offering. And what that means is you're not focused on the underlying operating system or underlying infrastructure that's running your applications. What you do is you build an application, you give us the application, and then we run it for you. And so it allows us to do a number of interesting things, one of which I called out here, which is things like automatic operating system patching. So since we're running your application for you, we have the ability to do things to patch the OS, to scale it out very, very easily and dynamically and so forth, because you've just provided us with the app and then we're actually running it on our infrastructure within the operating system. It's very scalable. So within Windows Azure, you have the ability to scale out your instances so that you're running across many different compute instances. And then from a storage perspective, we have a highly available storage service as well, which makes it easier for you to use for things more like binary type data like imagery and so forth that you can store in a highly scalable storage system. It's also a utility billing model in the sense that you only pay for the resources that you actually provision and run. So when you start off, you can start very small, and you will only pay for those resources. And as you grow and you need to scale out, you'll just continue to pay for those resources as you go. So it's a utility billing model. And then, well, actually not finally, but within the Windows Azure platform, there's also a number of additional services that are pretty compelling, and we'll talk about a few of them today. Things like the Access Control Service, which you heard Scott Guthrie talk about yesterday, which provides identity federation to a number of different social identity providers. Traffic Manager, which does intelligent DNS routing worldwide so that you can make sure that your users, wherever they are geographically, go to the nearest data center to them in order to serve up compute resources. We have a caching service that's distributed in-memory caching service, a content delivery network, and there's a number of other things. So with Windows Azure, it's not just core compute or core storage. There's other additional services that are compelling as well. And then lastly, if you're building for Windows Phone 7 and you're building for Windows Azure, there's a lot of common development tools. So Visual Studio probably being the one that comes to mind first. It's the same IDE across both environments. You can target the same languages. And then also for both Windows Phone 7 and Windows Azure, we have a set of emulators that run locally on the laptop that make it possible for you to do all of your development locally without having to tap into any resources off of your machine. So these are just some of the reasons that I came up with in terms of why Windows Phone 7 and Windows Azure seem to make some sense in terms of developing. And I thought with that, I would jump directly to a demo and actually show you an application that I built to try and highlight some of these capabilities. All right. So what I've got is an application that I call BabbleCam. And what BabbleCam is it's an application that allows me to take a picture of an image, and it will then allow me to upload that picture. Windows Azure will pick it up. It'll run it through an OCR service and then translate it and send me back the translation. And so what I'm going to do here, and this is going to be a little bit awkward because I had to print out a few things here to make this work. Very first thing I'm going to do is enable push notifications so that once the translation is complete, it's going to send it back directly to my application so that I can see that translation within the application. Then I'm going to turn on the camera. And here's what I'm going to be taking a picture of. This is from the visitmix.com website. And I'm going to go ahead and take a picture of it. Okay. Here's the picture. I'm going to go ahead and accept. Now, when I go to upload, you can see the picture, and I also can say the language that the picture is of, and I can choose a language to translate it to. So in this case, I'm going to choose French. I'm going to go ahead and upload. And so what it's doing is it's taking this picture and it's putting in blob storage within Windows Azure. Then I've got a service that's running and monitoring it. It's going to grab that image, run it through my OCR. It's going to then pass it to the Bing Translator service, and then it's going to use Microsoft push notification services, and you can see it sent it right back to the device. So I was able to take a picture from here and get a translation of it. Now, I'll be honest, the OCR service I'm using is an open source OCR service. It's got some challenges, but I do see some words that look French. So I can't read it, but one thing that's kind of interesting as well is I can come in here and I can see here's the translation that just took place. Go ahead and select it, and I can load the image directly out of blob storage as well, so you can see this is the picture that I took that it ran the OCR service on. So pretty cool. I thought I would do one other thing since I'm at it. Try this again. So here I've got some French. I took this from a newspaper online this morning. And to demonstrate that the OCR service works a couple of different ways. Now I'm going to say, go from French to English. And it's going to move this image up into blob storage. My roles should eventually pick it up. And then let me come in here, go ahead and refresh this. And then you can see here is the English translation of it. So Windows 7 Mango mixed to the second keynote of Microsoft MIX11. So you can see it's translated that French into English. So it's a simple Windows Phone 7 application, but it's using a number of pretty interesting services running in Windows Azure in order to power kind of a useful scenario. So I wanted to lead with that as a demonstration of why Windows Azure is a bit of a compelling choice for running with Windows Azure. Or excuse me, Windows Azure is compelling for Windows Phone 7. And really just kind of fine-tuned everything today and got things loaded. So I will be publishing the full source. So if you're interested in all in terms of how the OCR service works, or how I'm doing the Bing translation, or anything else, even from the Phone 7 application, I'll have that all available up on my blog. Now I want to walk through what exactly took place here. And you see a number of different components that are involved, starting with the phone. And the very first thing that occurred was I authenticated, my phone application authenticated to some services running in Windows Azure. And so a username and password were provided to a membership service running in Windows Azure, and a forms-based cookie or a token was sent back, which I then store in isolated storage on the phone device. Now the reason I do this is I'm going to be connecting back and forth to services running in Windows Azure, and I don't want to have to log in each time I make that connection. I'm going to embed that token with each request so that the next time I want to do something like store an image in blob storage, what I can do is simply pass that token that I've cached in isolated storage to my service endpoint. It'll use that to authenticate me, and it'll allow me to do some interesting things. In this case, since I want to upload an image into blob storage, what it's going to do is generate a shared access signature and send it back to the client. Now, a shared access signature is a component of Windows Azure Storage, and what this allows me to do is access secure and private storage containers running in Windows Azure without having to know the actual underlying key that is used to secure it. And so a shared access signature is created that gives me short-lived period in which to interact with my storage services in a secure manner, and then I can use that shared access signature to take the image that I took and push up into Windows Azure Storage. So the shared access signature is a great way to say, hey, I don't want to have to push this binary file, this very large image, to a service running somewhere else that then is going to move it into storage. The shared access signature lets me go directly to storage in a secure fashion. And what I want to point out is my actual Windows Azure Storage account key is never on the device. So if someone does get my device and gains access to it and so forth, that key is still secured up in my services running in Windows Azure. It's never made it down to the device. So the shared access signature provides a lot of security in terms of users using your application. Now, once I've uploaded that image, I said that we're going to do some processing. And so I have my worker role running that's periodically going out to my storage account and saying, hey, is there an image that I need to process? And when it finds it, it's going to pull that image into a service running in Windows Azure, and it's going to do some image processing. Now, one of the reasons that I think Windows Azure here is pretty interesting is I perform a number of modifications to the image before I run it through the OCR service. So when I grab that image, I will actually create, I think, 4 or 5 different images in which I adjust the brightness of the picture. I will make it black and white, and I'll also adjust contrast. And the reason I do this is I want to get the most accurate output from my OCR service as possible. So I'll make a number of copies of that image, adjust various characteristics of the actual image that was taken, and run all of them through the OCR service. When the OCR service completes, it's going to tell me a confidence level for each one of the images that it processed. And then I'll choose whichever one has the highest level of confidence. And then that is the image that I will then, or excuse me, that's the text that I will send to the Bing translator, which will send me back some translated text. So at this point, I've taken a picture, I've uploaded it, and I've run the OCR service and translated the text. Now I want to get that back to the phone. And so my Windows Azure services will then send a notification using the Microsoft push notification service. And it's the actual push notification service that will then send that data back to the phone. And I'll walk through a little bit of that architecture and what it means to use that push notification service soon. But this is really, when I gave the demo, this is exactly what happened. And these are all the different steps. Now, within there, I think are four key pieces, 4 core elements that it's worth exploring a little bit more in depth. The first is identity and understanding how do you understand who it is that's using the application, how do you securely share and give them access to resources and so forth. Then there's storage, and there's a number of different storage options within Windows Azure, and we'll talk through some of them. Also services, and just running services within Windows Azure, things like the OCR service that grabbed the text out of the image, as well as interacting with other services that can perform some modifications. And then finally, there's the communications aspect, and that's how do I then get data back to the phone. So I want to talk through this. One thing I want to point out, though, again, is that there's no one truth here. There's many different ways to go about doing these things, and based on my experience, these are some of the various options that I'm going to end up sharing. So there's no, the idiom is there's more than one way to skin a cat, and what I'm going to share are some options that I think are particularly good in working with Windows Azure. So for identity, probably the simplest way to approach identity is what you saw in the demo that I shared there, where I have my own model that I use for identity. I use the ASP.NET membership provider, and when my user initially logs in, they send a username password securely over HTTPS, and then I use under the covers the ASP.NET membership provider to manage and track and authenticate these users. And so this is a very, I think, common way to do it. A lot of the applications that I use on my phone, such as the Twitter client and so forth, at Twitter, there's a number of applications where I initially log in with a username password. Now, one thing to note is, in this application and many others, rather than always having to have the person log in with the username and password, it's also a common practice to take the token that is generated and sent back to the client and store that token. And you can set expiration on the token so that you can expire it after a period of time, and the user may have to log in again and so forth. But that way you store the token, and you can just use that token whenever you're making requests to services that are being used by the application. Now, another model is using a single existing identity provider. And I mentioned Twitter, the Twitter application. When I use that, I'm actually using my Twitter account. There's applications that can use Live ID or Facebook to authenticate. And so you could certainly build out your application such that you're using one of these existing identity providers, and you're using their APIs and working directly with them in order to authenticate users into your application. And that's a perfectly legitimate way to do it. And then the third option is to simply outsource that identity management to a completely different service that gives you a lot of capabilities. So the example here would be the access control service. And so you can outsource that identity management in such a way that a user could present any number of individual identities. It could be their Live ID, or it could be their Facebook account, or something else. And access control service actually manages the relationship between the identity that they provide and the identity that your application interacts with. And what I wanted to do is at least call out here that Vittorio, who's one of my teammates sitting in the front here, has recently published a hands-on lab that shows exactly how to do this, authenticating users in Windows Phone 7 using the access control service. And so I definitely recommend. We've got there's a bit.ly link here that you can go to that'll take you directly to the resource. Take a look at it. This is a fabulous way of going about leveraging other identity providers to authenticate and authorize users within your application. So storage. Now, I said within Windows Azure there's a number of storage options, and so I want to talk through a couple of them here. The first is SQL Azure, and most of you are familiar with SQL Server. Well, SQL Azure is a service running up in the Windows Azure platform that provides full relational database capability. And so whatever you're used to doing within SQL Server, like interacting with stored procs or table triggers or whatever it is that you end up doing, these capabilities exist identically in SQL Azure. And so you can have your application and your phone applications interact with SQL Azure in a number of different ways. SQL Azure is compelling because it's managed as a service for you. So unlike running SQL Server locally, this is a managed service where you simply create your database and the resources and objects within it and interact with it without being responsible for running, installing, setting up, and managing that database. And so SQL Azure is certainly one capability. Another one is Windows Azure Tables. Now, Windows Azure Tables are part of the Windows Azure Storage Service, and they provide non-relational structured storage to your applications. In fact, in the application I showed you, the BabbleCam, where I'm storing the actual translated text in a set of Windows Azure Tables. And so then I can make queries against it using OData to call back and to return the data that I want. And Windows Azure Tables are nice because they do provide for the ability to massively scale out based on usage. So you have the ability to partition it in advance so that if and when the access and calls against your tables grows, it can manage that latency for you and scale it out pretty massively. And then the last is Windows Azure Blobs. And so this is basically just big files. It can be binary data. It can be really any kind of data that you want to store in there. And the example here would be the images that I take and upload into Windows Azure. I'm storing within Windows Azure Blobs. And you access Windows Azure blobs via a REST head. So it's very easy to interact with from a number of different platforms, technologies, and devices. So I thought we'd walk through a couple of different patterns and ways to interact with it. So for instance, with SQL Azure, a pretty common pattern is rather than having the phone calling directly to SQL Azure itself, is standing up a web role that has a service, could be an OData service, that itself is then interacting with SQL Azure. And so you proxy the communication to SQL Azure through this service that's running up in Windows Azure. And so this is a great way if you need to have relational data available to your users, you can expose it through a set of services that your phone interacts with, and then that service is interacting with SQL Azure itself. Now, one thing to point out is that there is a CTP environment for SQL Azure called SQL Azure Labs, and I believe it's actually SQLAzureLabs.com. And they have a CTP offering of an OData head on top of SQL Azure that they manage and run for you. So if you wanted to give it a try, you can log into SQL Azure Labs and put in your credentials to your SQL Azure database and turn on this OData head in which they have a service running for you that you can communicate with in order to interact with your data. So essentially, it's taking the web role out of this picture and using this OData head provided by the SQL Azure environment. So you can take a look at that. That's a pretty interesting concept. Now, another way is with Windows Azure blobs, you can have public blobs. And so the scenario here is that the client sends data to a web role, and that web role will write the data to the actual blob. And then from there, the client can read those blobs directly from Windows Azure Blob Storage. Now, the reason it writes to the web role is you cannot write directly to a blob without having the actual account token. And so the web role has the token that's used for Windows Azure Storage, and it has the ability and the access to write to blob storage. So just because it's a public blob that can be read publicly, you still need to have the underlying account key in order to do the write. And so rather than putting that key on the device, which could potentially cause it to become available somewhere else, you want to make sure that that key lives in your service and that the service is responsible for doing the writes. So this is a pattern for interacting with public blobs. Now, another pattern for doing this is saying, let's get the web role out of the way and have the phone write directly to storage. And this is where we use shared access signatures. And so in this scenario, I would call out to a web service and say, hey, give me a shared access signature to blob storage. And it would return back a shared access signature, which then I would put within my request header so that I can interact and write directly to blob storage myself. And the reason this is interesting is because it gets the service out of the way. So if I have binary data I want to write into storage, rather than writing it through something that's proxying it for me, I can write it directly into blob storage. And so this is what the phone application I demonstrated, what BabbleCam does, is I get that shared access signature, and then the image that I take a picture of, I write directly to blob storage in a secure fashion. And why this is secure is the actual authentication token used to write to the storage never ends up on my device. The shared access signature gives me a short-lived policy that gives me the ability to write to that container. So this is a compelling way to securely write directly to it. And then from there, I can just read directly from storage. If it's public, I can read publicly. If it's a private container, I can use that shared access signature to read. Now, for Windows Azure Tables, there's not a concept of a shared access signature. And so when you want to interact with Windows Azure Tables in a secure fashion, you will always end up using a proxy in order to do so. And so this is very similar to the pattern that we showed for SQL Azure in that I will send my request to a service. That service will interact with then, oops, it says blobs, but it should say tables. That service will interact with the Windows Azure Tables for me. So if I want to insert some data, I will send it to the service. The service then puts it within the tables for me. Similarly, if I want to retrieve information from tables, I will also go through that service proxy. And so all of this, what I really want to highlight is don't store secrets on the phone, because if you do that, they're no longer secret. So the best practice is to always make sure that your secrets that give access to your resources stay in services that you manage, rather than being embedded in an application that runs on a number of other different devices. All right, so now let's talk a little bit about services. The first thing that I wanted to talk about was a web role versus a worker role. And the reason I wanted to mention this is because over time, especially over the last year or two, the differences between web and worker roles is decreased in a little bit. It's decreased a bit. One of the core differences between a web and a worker role is that a web role has IIS installed on it. A worker role does not. Traditionally, when you interact with the worker role, it's very similar to having a Windows service in Windows Server, where it's essentially a DLL with a main. It's just a service that's running and doing a bunch of stuff. You don't have IIS on it, so you're not hosting a web server. You're not running web applications and so forth. It's just doing some kind of work. Whereas a web role, since it has IIS installed on it, is something that actually can serve up web services, websites, etc. Now, the reason I think this is kind of an interesting thing to talk about is one thing that has changed over the last couple of years is that a web role also inherits from the role entry point in a class called webrole.cs. And what this means is you can run many of the same background type tasks that you do in a worker role in a web role. So the web role has IIS, but it also has this role entry point where the Fabric controller, which is responsible for managing our applications for us, will call into to start processes. And so in your web role, you could theoretically, in fact, BabbleCam, the application I'm running, is really just one web role, two web roles, but no worker roles, because I'm running all that background processing within this webrole.cs that's being called into through the role entry point. And so it's just an opportunity when you're looking to optimize the number of instances you're running and the number of applications you have deployed to Windows Azure. There are opportunities to consolidate things like background tasks and work onto the same server that's serving up your services in your application. So that's an opportunity. Now, there's reasons why you may not want to do that, and I'll talk through how you traditionally scale work in Windows Azure. And the way you go about doing this is traditionally your application will be interacting with services or an application running in a web role. Now, that web role would end up enqueuing work, and so Windows Azure Storage also has durable storage queues, and so it would enqueue that work into this queue service. From there, you would have a worker role that's monitoring the queue that will then dequeue that work and end up doing whatever that work is, such as pushing notifications through the Microsoft Push Notification Service. Now, the reason this is a compelling architecture, rather than having that worker role work running on the web role, is I can scale these things independently. So it may be a case where the type of work that I'm doing on a worker role is such that I may want to scale that far more than I need to scale my web front end based on the number of requests that I'm handling. So by decoupling these items and putting them in different roles, I have the opportunity now to scale each of these pieces independently based on the underlying workload. So this is a pretty traditional pattern and a way of scaling out work within Windows Azure. Certainly everything could be done in the same web role instance, but there are times where you may not want to do that and you want to split it out. I also wanted to talk about multi-tenancy because a lot of folks that I've talked to that are building mobile application, they have many different sites that they want to run, and it may not always make the most sense to have individual web roles and web role instances each running one application for them. And so with the updates that came with the Windows Azure SDK 1.3 last November, we have the ability to actually define multiple sites within our role. And what this means is I can have multiple applications, web applications, running in IIS, servicing up and handling different types of traffic. And so you can see here I included some code which shows how you express this within the service model within Windows Azure. And you can see that I have a sites collection, and in there I have multiple sites. So I have the top site is a web. That's my default web role. That's going to be installed into my default instance. But below that, I have a separate application pointing to a different directory that's going to be also running in IIS. And you can see there's a host header name. And so the way this works is I can deploy multiple sites into IIS and then route traffic to them appropriately based on host header information. And so I have my own domain name, litware.com or wadewegner.com, whatever it may be. I can create a CNAME that points to my cloudapp.net application, and then when the traffic is sent to it, it's going to analyze the host header information. It'll see that it's someapp.wadewegner.com and route it to the appropriate site. And so this way I can run multiple web applications in the same web role instances rather than having to have a whole lot of them running each independently. And so this makes a lot of sense in cases where you can handle the traffic and the load all in the same web role instances, and you don't need to necessarily have these things running independently. So it's certainly possible to accomplish this type of multi-tenancy within Windows Azure. Another thing that I wanted to mention is the content delivery network. And so what the content delivery network is it's a set of data centers that we have worldwide. In fact, I think, Steve, there's 24 of them. And as Steve pointed out yesterday, by the time you're watching this recording, there's most likely more than 24. But there's 24 CDNs worldwide that can cache data, such as images and other things that are stored within Windows Azure blobs, can cache that data locally so that when a user goes to retrieve it, if that data is available within the CDN, it doesn't need to traverse all the way to the data center where my actual Windows Azure storage account is. And so you can essentially see all these nodes. So my devices, as they're interacting with some of these static resources, can use some of them that are closer to them so that you can reduce some of the latency when trying to pull that. So the content delivery network is a nice way, a nice additional capability here. We also announced yesterday a new service that's coming as a CTP, as of yesterday, I believe, called the Traffic Manager. And what the Traffic Manager does is it intelligently routes your traffic to the closest or most appropriate data center based on rules and policies that you define. And so what you see here is a case where I may have an application running up in the North America. I may have my application also running in Asia, and I may have it running in Europe. And I don't want my users to always have to go to one particular data center, and I want to route them based on where they're located. So the Traffic Manager is able to determine where the user is coming from such that it routes them to the closest data center so that it reduces the latency. So I no longer have to only run my application in North America and then force users in Asia and Europe to go to that data center. I can run my application in multiple data centers and then use the Traffic Manager to route that traffic intelligently. So those are some of the services that Windows Azure provides. I also want to talk through some of the communication patterns and how you can have the phone interacting with Windows Azure. There's two primary communication models here that we'll talk about. The first is phone initiated. So I do something on the phone that goes off and tries to grab some data and pulls it back down. And then another one is cloud initiated, where something happens and I want to send information to the client. In fact, the BabbleCam application, I demonstrated both of these scenarios. The phone-initiated one was where I refreshed and pulled out my list of translations under my Babbles. And then the cloud-initiated one was the notification service message that pushed the translated text directly to the phone. Now, with phone-initiated communications, there's a number of things to be aware of. Traditionally, it's all HTTP-based, and it's based on request responses. So I'll make a request to a resource, to a service, to an endpoint somewhere, and I'll get a response back. And so this is very much of a polling type architecture where I may go out and look for something periodically, or it could also be user-initiated, where the user clicks the refresh button, or the user browses to a particular page within the application. There's a number of different frameworks that work with this. So you could have a service running via WCF or OData. You could just make web request calls directly. And then there's a number of different wire format options as well. So SOAP, JSON, and plain old XML, and others. So there's a lot of different options in terms of how you can go about this phone-initiated communication. The cloud-initiated communication is pretty interesting. And so this is where we're leveraging the push notification services provided by the Microsoft push notification services. And so one thing to note is, and many of you probably are aware of this, but there's only going to be a single connection between the phone and the Microsoft push notification service. So my cloud application cannot push directly to the phone. I have to send the message through the Microsoft push notification service. One of the advantages to this is that it's very bandwidth and battery friendly. So there's not a whole bunch of applications that are all getting information sent to it from a bunch of different services. It's only communicating with the Microsoft push notification service. One thing to note, though, is that there is no guarantee of delivery of the messages coming through it. Although, in my experience, it's delivered just about every message. Now, there's three kinds of push notifications that are available to us. The first is raw, and so this is where you can send a raw message directly to an application. The BabbleCam application used a raw message that was pushed directly to the phone client to display the translated text right within the client. But there's some other ones as well. There's also toasts, so I can push a notification to a user and it can pop up within the within the phone as a toast notification, so basically the blue bar at the top, and it'll show that message. And I can also send a tile notification where I can update the actual live tile on the phone with either a new image or title or even increment a counter on it. And so looking at how this works is, we'll walk through what it means to subscribe to push notifications. The very first step is you first have to initiate the subscription to the Microsoft Push Notification Service. So in my application, you saw me click on the Enable Push Notifications. When I did this, what I did is I went off to the Microsoft Push Notification Service to open a channel, and then I send the URI to my web role. So that URI then becomes something that my web role, my application, uses to communicate to the Microsoft Push Notification Service. So now when I want to push a notification to the phone, I use this URI, send a message to the Microsoft Push Notification Service using it, and then Microsoft Push Notification Service is able to send that message down to my phone. And so this is the pattern to go about doing it. It's a pretty neat pattern and opens up a lot of opportunities. Now, everything that we walked through is probably a lot of information, and I went through it reasonably quick. And I alluded earlier to the fact that much of my experience comes from building out a toolkit to make things a little bit easier. And so what I wanted to do is talk a little bit about what there is available to make using Windows Azure easier. And so today we actually released, well, actually last night I published it, so an update to the Windows Azure Toolkit for Windows Phone 7. So we've released the first version about 3 weeks ago. And the first version largely provided a set of services for interacting with Windows Azure storage, so blob storage and table storage. And it provided a base level set of membership services that allowed you to interact securely with storage. What we've done this time is we've provided a out-of-the-box support for a notification service running in Windows Azure as well. So everything you saw me demonstrate in the BabbleCam application, I used the base set of services provided by this toolkit. And so the ultimate purpose of this toolkit is really just to make it easier for a Windows Phone 7 developer that knows developing for Windows Phone 7 well to use Windows Azure, and to make some of the learning challenges and so forth a little bit easier when leveraging Windows Azure. And we do this by providing a set of client libraries. So we provide a client library for Windows Phone 7 for Windows Azure storage. We have a number of sample applications that are part of the toolkit. We have source code, documentation, and we also have project templates that make it pretty easy. And so what I wanted to do now is demonstrate exactly how to leverage this toolkit. So let me switch over. So here's the Codeplex site. So it's an open source project. You can look at all the source code, even our client storage library. If you go under source code or if you download the package, we provide the full source code in both C# and VB.NET for how we interact with Windows Azure storage. So you can go to downloads and download it. We've got documentation and other things you can take a look at. I've already downloaded it. So when you finish the download, you're going to have a self-extracting executable file that you can go ahead and run and unpack on your system. So one of the things that's nice about this is we're not registering anything on the computer itself. We just unpack a whole bunch of resources. The primary reason we use the self-extracting executable is when you download zips, traditionally it's blocked, and so you end up having to unblock the zip, and then you get a bunch of warnings in Visual Studio and so forth. And so the self-extracting zip is a really nice model. Now once it's unpacked, I'm going to go ahead and run this setup. And we've got a dependency checker and a wizard that will walk through and make sure that all the things that I need access to are on my machine, and if they're not, it'll tell you where to go get them. So it's going to run through and check a whole bunch of things to make sure that all the core dependencies needed in order to utilize this toolkit are on the machine. And so you see we check a whole bunch of things. Here's an example of a warning. So there's actually a separate download for the Visual Basic for Windows Phone Developer Tools. And we'll provide a link if you wanted to go download that. Once it's completed the dependency checker, I then click Next, and it's going to register a Visual Studio extensibility file, so a V6 file, that provides all the new project templating that you can use in order to build out these cloud-enabled Windows Phone 7 applications. So I'm going to go ahead and install, and once that's installed, when I open up Visual Studio, I'll show you my extensions manager, and you can see here that I've got the WAS toolkit for WP7 installed. And so this gives me all the project templating that I need in order to move forward. So now if I go to File, New Project, and then take a look at the cloud projects, you'll see that there's 2 new project templates available here. We've got Windows Phone 7 cloud application and a Windows Phone 7 empty cloud application. So we actually mimicked the ASP.NET template model where the Windows Phone 7 cloud application includes a default application that shows you how to fully leverage the storage client library, how to interact with the push notification service, and so forth. So it's a out of the box. You can hit F5, and I'll show it to you in a moment. It's an application that you can use to get started. The Windows Phone 7 empty cloud application is really just a Windows Phone 7 project, a set of Windows Azure projects with all the references already set up for you, all the storage client libraries and assemblies registered in the appropriate places, but no real application built into it. So it's much more of a start from the very beginning and build out your application. But at least it gives you all the scaffolding and everything that you want, that you might need right off the bat. So I'm going to go ahead and create this cloud application, and it's launching a wizard. Now, the reason we launched this wizard is there's 2 options here. If I want to develop locally, I can use the local storage emulator, and I can click that checkbox. Or if I want to just leverage my Windows Azure storage account that's running out in Windows Azure, I can put in my account name and the storage account key. And what it'll do then is store that information in my Windows Azure web role securely. And as I use this application and run with it, it's going to leverage the actual storage system. Local development experience here is pretty nice, so I'm going to just use the local storage emulator. I'll go ahead and hit OK. And so it's creating it's creating the actual solution that has all these components. And you can see over here, I'm going to go ahead and zoom in a little bit. I've got a cloud services project. So that's what that top one is. That's a Windows Azure Cloud Services project that links to a web role called WP7 Cloud App 7.services. And so that's a web role that's here. I've also got a phone project. So this is a Windows Phone 7 project that's been created that already has a number of things referenced, such as this Windows Phone Cloud Storage Client Library, which we've created. And it's pre-configured and set up with an application that already is able to use the Windows Azure projects. Now, we also have this template, this introduction. I know, at least in my case, I very rarely read the documentation. In this case, it is actually a nice walkthrough that will walk through all the different steps in order to leverage this and kind of explain it. So I encourage, if you want to give this a try, to take a look at it, or you could just hit F5 and get things launched. And so when I hit F5 now, by default, it's pointing to the device rather than the emulator. Apologies. Change that. And what it's doing is it's starting up the Windows Phone emulator, as well as down here you can see I've got the Windows Azure compute and storage emulators running. And in fact, if you guys aren't as familiar with Windows Azure, I can show the compute emulator. And you can see here's my services web role. I've got an instance running locally in the compute emulator, and here's a browser that is launched. Now, I've got a certificate notification here. The reason I have this is by default, all of our communication to services goes over HTTPS. That's the best practice. We don't want to be communicating over HTTP with sensitive information. And so locally, what we use is a self-signed cert to interact with these web services. So since it's self-signed and it's not signed by a trusted authority, you're going to get this warning. And this warning's OK. So just go ahead and click OK. We're going to continue to the site. And you'll see that we have a default kind of MVC2 application running here. Now, the reason this is an MVC2 application, by the way, is the current Windows Azure tooling only supports out-of-the-box Windows Azure, MVC, ASP.NET MVC2. We'll support MVC3 soon, and when we do, we'll update the toolkit. But that's the reason why this is running ASP.NET MVC2. So the application's running, and I can come here to my phone emulator and go ahead and open the application. Now, the phone is also going to be communicating over HTTPS to these services. And so there's a trick in order to get this to work. Now, the phone will not communicate to a SSL, or will not communicate to a service running in HTTPS unless, one, the certificate is installed on the phone, or two, it's a trusted certificate. And so since I'm using a self-signed cert, if I tried to interact with it directly, it would fail. It would not work. So what we have here is the ability to go ahead and click this link to install the cert. So here's the cert that's being used. I can click this. It's going to allow me to install the certificate. It installed OK. and now I can come back. And now as long as I keep the phone emulator up and running, even if I redeploy my application to it, as long as the emulator is up and running, the certificate has been installed into it, I don't have to do that step again. Now, by default, the user doesn't exist. And so what I'm going to do is go ahead and come here and create a new user. I'm going to say this is demo at mix.com. Give it a very secure password. I'm going to go ahead and register that user. And so it registered that user successfully. In fact, I can come here and log in. And hey, turns out we provide you the administrator username and password so that you don't forget it. Log in, and you can see here now that I have my user. So by default, my user is set up to have permissions to my sample data. It's got has access to tables and blobs and so forth. So you can see that that user exists now. We also have this push notifications tab. And what the phone has done is, that's actually a different, that's not this user, that's a different user, not the demo user. I'm going to go ahead and log in. And you'll see right here we have this button to enable push notifications. And so I can go ahead and check this. And when I come back here and refresh the page, once it's established the connection, we'll see that demo user appear. So it's registering with push notification service. Hopefully that will register. Usually doesn't take this long. All right, well, we'll come back to that in 1 second. So hopefully that'll register by the time I come back. We have it set it up so there's a number of pivot pages here. So if you pivot over, you'll see a table list. And the table list actually shows how to use the storage client library provided for the phone to iterate over the tables that I have within the application. And so you can see here that it shows you a way to create new. So I can go ahead and add a new table. And it's just going to create a table. And it shows that I can delete tables and perform these type of operations. I also have a table called sample data, where I can show how I can create new rows of data within it as well. So I could say mix demo, saving some data, and I can even put a number. So this is just sample data. Go ahead and save that. And when it reloads the list, we'll see that, okay, that was just the push notification error timing out. So that timed out. You can see here, though, it still did load the table data. So here's that mix demo saving some data. I can come back here as well to go ahead and delete it. And still the registration error. That's nice. And let's go ahead and close that. I'm going to go ahead and let me restart this real quick. Hopefully that was just a temporal thing. Try running it again. So the BabbleCam application that I used the same set of notification services. The only difference being that I took the web role that runs all these services and deployed it up into Windows Azure. So I'll get this running again. Come back here, open up my app, see if we can get this channel to connect. Oh, sorry. Install the cert. Log in. All right, so let's try to enable the push. Registering with push notification service. Good, so that connected. Let's go ahead and log in here, and we can see that that channel is available. Push notification. All right, so here's my demo user. I can say, hi, demo user. Send a raw message. Sent to the device successfully. Here's hi, demo user. So it demonstrates how from my web application running in the emulator, or it could be running in Windows Azure itself, is able to send a raw notification to the client. Now, there's more that we can do as well. So let me go back here, and I'm going to add this application and pin it to start. And I can come here now and say toast notification. Send this as a toast. I can also, you can see here's the toast. I can also end up sending a message to the tile, so tile notification. And by default, it's going to increment and provide a number, so to show you the message. And if I select this, it's logged in since I remembered it. And you can see both my tile notification and toast notification are available. Now, with the current set of tools and with the current notification service, the way in order to accomplish this, and we've built this into the library, is when we send the notification to the tile or as a toast, we also store that message into a Windows Azure table, so that if the user clicks it or clicks the tile or the toast, when they come back into the application, it's going to list out the most recent messages that were sent back or sent to the user. So that within my application, I'm able to see them as well. So in a case where I may send a toast notification that's particularly long, and I can't read the entire toast, or if I just want to send some updates and provide a visual indicator that there's updated information on the tile, the user can click the tile, and then when they open up the application, the data that you've actually sent is available to them within the app. So very useful for the cloud-initiated communication scenario. So that's the toolkit and some of the things that it provides. So if I use this for building out the BabbleCam, the most complex part of the BabbleCam application was really just the open source OCR service that I leveraged. Everything else, I basically used the tooling provided by the toolkit and then modified as needed by my application. And so with that, let me come back. So I'm going to go ahead and quickly go through and summarize the talk, and then I would love to, if you have any questions, feel free to ask. But essentially, the whole premise of this talk is that the phone loves the cloud, and the cloud loves the phone. I mean, work very well together. Think about these 4 different scenarios, so identity, storage, services, and communication, and how Windows Azure plays a piece in these areas. And then also take a look at the toolkit. And I would love to get feedback if it's something that you find useful, and if there are scenarios that we should target as well, let us know. And so with that, thank you very much. And if you have questions, please come up to the microphone so that we can get them recorded, and I'm happy to answer them. Thanks.
Can you share your thoughts on considerations if you're going to support more than just Windows Phone? So if you're going to support Android and iPhone as well, using this toolkit.
One of the things that I led with was I think Windows Azure provides a great opportunity to provide a set of services that can be used across platform devices. So I think it's definitely something that you should consider as mobile and phone app developers. And I will point you to Simon Guest's talk tomorrow. So Simon Guest is sitting up right here, and he's going to be giving a talk on building iOS applications that use Windows Azure. And so I think many of these scenarios, in fact, well, I don't want to give anything away from his talk, but I think he's leveraging a bunch of services running in Windows Azure for iOS devices. So I think it makes a lot of sense. Any other questions?
Hi. When you talk about the traffic manager, you talk about deployment in different data centers.
Yep.
Is the traffic manager need to be charged separately? And in those scenarios, what should we do to synchronize our application in different deployments in different data centers?
That's a good question. So I think the first part was cost related, right? Are there cost considerations for traffic manager? And at this point, we've made no announcement on pricing. I have no idea if and what the pricing model will be for traffic manager. So we'll have to wait. I'm sure there'll be an announcement at some point before too long. Now, the other thing that's interesting about it is what this means is I've got applications running in different data centers, different compute instances, presumably running with information in storage that could be across multiple data centers as well. And how do I synchronize that data? There's a couple of options. The first is for SQL Azure, we have the SQL Azure Data Sync. It's in CTP right now, but the SQL Azure Data Sync is a method whereby you can synchronize SQL Azure databases across multiple deployments. So Data Sync would be a great way to synchronize databases that live in different data centers. So in Asia, I may have a SQL Azure database that's being serviced by my applications running in Windows Azure Compute. I may have another one in Europe and another one in North America. SQL Azure Data Sync synchronizes these databases across all of them. From the Windows Azure storage side, we've talked about at other conferences that we are putting some efforts into synchronizing Windows Azure storage across data centers as well. I don't have any Anything additional to share that we haven't said before? Today, you could manage this yourself. So you could end up writing a set of services that runs in, let's say, a worker role that's solely responsible for synchronizing data across storage accounts in different data centers. So there are opportunities to do it, some of which we provide as a service in the case of SQL Azure Data Sync, some of which you can write yourself today for like Windows Azure storage. Any other questions? All right, well, if you do have questions, feel free to just come on up and ask them. But thank you guys very much.